Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer B, well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So a planet has a radius r and a density ρ. The gravitational field strength at the surface is g. What is the gravitational field strength at the surface of another planet of radius 2r and density 2ρ? So I'm going to start by thinking what equation is going to be helpful in answering this question. And the obvious equation is gravitational field strength is equal to the gravitational constant multiplied by the mass of the planet over the distance from the centre of that planet squared. But in this question, we're not given the mass, but we do know that the mass of any object is equal to its volume multiplied by its density. And we know that the volume of a sphere is 4/3 pi, and I'm going to use capital R for the radius of the sphere cubed. Therefore, the mass of a sphere, or the mass of a planet, is going to be equal to 4/3 pi r cubed multiplied by the density. So I can substitute this for m into this first equation, and I'm going to get the gravitational field strength on this first planet is equal to the gravitational constant multiplied by 4/3 pi r cubed ρ all over r squared. Well, we can see these r's are going to cancel, so I end up that the gravitational field strength of this planet is g 4/3 pi r ρ. Okay, so now let's look at this second planet, and we've got to find the gravitational field strength for this second planet. I'll call that gravitational field strength G2, and I'm going to use the same equation with just a subtle difference. So it's G 4/3 pi. Now the radius is 2r, so I need to put 2r in here, and the density is 2ρ, so I need to put 2ρ in there. Now, some of you may see exactly where this is going, but I'm going to rearrange this in a slightly strange way. I'm going to say that G2 is equal to gravitational field strength 4/3 pi r ρ multiplied by 4. Now the reason I've done that is to show you that all this is exactly the same as this here. So instead of writing G 4/3 pi r ρ, I could just write little g. So I could say that the gravitational field strength of this other planet is equal to g multiplied by 4, or G2 is equal to 4g. Answer B. If you found this video useful, please press the like button. Comments be welcome. Perhaps there's some videos you'd like me to make on a particular question, and I hope you'll share and watch more of these in the series.